want to go over a few special examples of functions. Honestly, I don't even think of them as functions as much as I think of them as sequences of numbers, but you can still think of them as functions, and they're worth talking about either way. So arithmetic sequences, this is not pronounced arithmetic, it's pronounced arithmetic, different from the word arithmetic. So it's something like this. So 5, 8, 11, 14, 17. The pattern that we're following here is that we're repeatedly adding 3 to get to the next number. So the next number in the sequence, you would probably, I would hope, guess is 20, because you could add 3 to 17 and get to 20. So you're just repeatedly adding the same number to get to the next element of the sequence. You could also repeatedly subtract. So you could do 21, 19, 17, 15, 13, down to like 5, 3, 1. It could like keep going into like negative numbers as well. So this would also be an arithmetic sequence because you're still adding the same thing, that except as the integer that you're adding is -2, which of course you could just think of this as subtracting the same thing every time. Okay, so arithmetic sequences, they start with some number, call that number A, and if you're just repeatedly adding the same thing, call that X, I guess. Then your sequence is going to look like this. So A plus X, A plus 2X, A plus 3X, so on and so forth. And your nth term is going to be like A plus n times X. By nth term, this, I guess if you consider this the first term, this would be like your n plus first term. If you consider this to be your 0th term, then this would be your nth term, but anyway, it doesn't really matter. All of these are going to have the form A plus n times X. This is your n equals 0 case. And we could see that this is like a function. So let's do like the 3, 5, 8 one. So we would view it as a function as like this will be like the 0th thing in your sequence, is the first thing in your sequence, is the third thing in your sequence. So 5, 8, 11, 14, 17, and 20, and so on. This would be corresponding to like n equals 0. Sorry, let me actually put that in there. N equals 0, and then this would be like your first term in the sequence, your second term, third term, fourth term. And with this, you could see like a general pattern. Like, what would it be for your nth term? It would be just 5 plus, you're repeatedly adding 3, so it'd be like plus 3n. Okay. And it's like you add it like n times. Here we've added 3 one time, so this is like 3 times 1. And then this would be 5 plus 3 times 2. This would be like 5 plus 3 times 3, and then 3 times 4 up here, and then 3 times n to get to your nth term. That's why I didn't want to have this as like n plus 1. Anyway. Geometric sequences are the other special case. So here it's very similar, except instead of adding the same thing each time, you multiply by the same thing each time. So here we have 3, 6, 12, 24, 48. So repeatedly we are, instead of adding something, we're repeatedly multiplying by something. So we multiply by 2 each time to get to the next number in the sequence. So the next number in the sequence would be, next number in the sequence would be 96. Okay. And of course you could have like division in here as well. So you could do like 48, 24, 12, 6, 3, 3 halves, 3 fourths, 3 eighths, just repeatedly dividing by 2, because dividing by 2 is like the same as multiplying by a half. And so if your first term in the sequence is a, your second term would be, if you're like multiplying by x, it would be like a times x, and then it'd be a times x again, or in other words, a times x squared. And then over here it'd be like times another x, you get a times x cubed. And then in general, you have a times x to some power. So putting this in a table, we want to do like, let's do the 3, 6, 12 one, 3, 6, 12, 24, and so on. So we'll call 3 our like n equals 0 term. We'll call 6 our n equals 1 term. This is 2, this is 3, and so on. And what would our nth term be? So this is basically a formula for the nth term of the series. So this is like 3 times 2. This is 3 times 2 times 2, or 3 times 2 squared. That corresponds to this being a 2. So in general, it's going to be 3 times 2 to the n. So that's our formula for the nth term of our geometric series. All right, cool. And yeah, that's it.